Hello everyone. I'd like to welcome you all to week 3. Just want to let you know that I'm proud of how hard you're working. Keep up the good work. I know these problems can cause you to think a little, but just keep up the good work and keep working hard. This week we'll be studying solving systems of equations. We'll have two equations and we'll want to find out where these can be represented by graphs, so we want to find out where the two lines intersect, if indeed they do intersect and all. And we have three methods to find that point of intersection or to solve systems of equations. One method is by graphing, one is by substitution, and one is by what we call elimination. So we're going to start off with solving by substitution. And your first objective in solving by substitution is to isolate one of your variables on one side of the equal sign in either one of the equations. So you want either the x or the y to be on one side of the equal sign in either one of your equations. In this particular problem that we have here, y is by itself in both of my equations. It's already isolated. So looking at the first y, it tells me that y is equal to 4 minus 2x. That means that y and 4 minus 2x are interchangeable. It tells me that wherever y is in my second equation, I can take it out and replace it with 4 minus 2x because y is equal to 4 minus 2x. And that's how you do substitution. That's called substitution. We're going to replace this second y with what y is equal to in my first equation, which is 4 minus 2x. So if I'm working with my second equation, then I can take this y out here and replace it with 4 minus 2x because y is equal to 4 minus 2x in that first equation. Now what that does for me is to give me one variable in this equation, and we've solved equations with one variable in them. So that's what I'm going to do. I'm going to solve this equation that I have now for x. So we'll add 3x to both sides. So we'll have we can combine our variables. So it gives me 4 plus 1x equals 7. And then we're going to subtract 4 from each side. That tells me that x is equal to 3. Now again, these two lines, if I was to graph these two lines on one coordinate plane, these two lines would intersect in this case at one point. And that's what we're trying to find. We're trying to find that point where it intersects. And you know that points they have an x and a y. So we've only found the x so far. So we need to also find the y. And to find y, all we're going to do is take one of our equations, one of our original equations. I'll take the first one, y equals 4 minus 2x. And then we're going to plug the x in that we just found in that equation, and then we can find out the y value that goes with that. It's kind of like that t-chart that you did. But this time we found out that x is equal to 3, so we need to find out the y that goes with that. So I'm going to replace x with 3 and work that out. So we get 4 minus 6, which gives us negative 2. So the point of intersection for those two lines is 3, negative 2. So that tells me I have one solution because those two lines intersect at one place. They intersect at this point 3, negative 2. Now the problems you have this week, a few of them will also ask for you to find your x-intercepts and y-intercepts of the lines of each equation and then graph. So let's quickly go back over how to find those x and y-intercepts. So if I'm working with that first equation, sorry about that line. Okay, so again, if I'm working with the first equation and I'm trying to find my intercepts, I have y equals 4 minus 2x. To find my x-intercept, I would replace y with 0. And then I would solve the equation. So I need to add 2x to both sides. That means I have positive 2x on my left-hand side equals 4. And then divide both sides by 2. X equals 2. So my x-intercept is 2, 0. Find your y-intercept for that equation. So to find my y-intercept, I would replace x with 0. So in that same equation, y equals 4 minus 2 times 0, and that'll help me find my y-intercept. So 2 times 0 is just 0, so y equals 4. Therefore, my y-intercept is 0, 4 for that equation. Okay? And what about that second equation that we have? Let's find our x and y intercepts for that one. So y equals 7 minus 3x. To find the x-intercept, again, replace y with 0 and work it out. So this time I'll be adding 3x to both sides. I have 3x equals 7. And then I will divide both sides by 3 to find x equals 7/3. So my x-intercept, 7/3, 0. That's the coordinates of my x-intercept. To find the y-intercept, we'll replace x with 0. And 7 minus 0 is just 7. So the y-intercept for that is 0, 7. So that's how you'll find your x and y intercepts. So we use substitution to find out that the two lines cross or intersect at 3, -2, which is one solution because they intersect at one place. And we found our x and y intercepts. Now what you would do, you would take these two lines, plot them on the same coordinate plane. You might want to use two different colors to plot those lines, but you'll plot them on the same coordinate plane to see where they cross. So in this situation, let's go back here. So that represents, the blue line represents my first equation, the y equals 4 minus 2x, I believe. The red line represents my second equation, and you can see that they intersect right here at that 3, -2 mark. So that's what my graph would look like, and that's the intersection. That's actually the solution of the systems of equations for those two. Okay. The next method we're going to use in solving is elimination. Now, elimination is different from substitution in that you want x and y on the same side of the equal sign together in both of your equations. Your objective in elimination is to have one of your variables to have the same number, but you want opposite signs. So you want like a -5x and a 5x, or a -10y and a positive 10y. You want them to have the same number but opposite signs. So in this case, I have 5x plus 6y equals 1 and 5x plus 35y equals 10. Well, my x's are very close to having what I want. They both have 5x, but they both are positive. So I need to make one of those negative. You can manipulate these equations by using multiplication. So what I can do is I can multiply this top equation by -1. And when I multiply that top equation by -1, I get -5x, and you have to multiply every term in there by -1 to keep the equation balanced, minus 6y equals -1. And that's just multiplying everything through there by -1. My second equation, I don't want to change it at this point, so because I want my 5's to be opposite on the x, and now they are. So I'm going to keep my second equation just like it is. Now, once you get that, you're going to add the two equations together vertically there, adding your like terms. So once you have one of your variables to have opposite numbers, same number, opposite signs, then you're going to add your two equations together. Well, negative 5x and positive 5x will simply go to 0. They'll cancel each other out. That's the elimination part of it. And then negative 6y and 35 is going to give me 29y. And then negative 1 and 10 will give me a positive 9. Okay, again, now we have that one variable that we can solve for. So I can divide both sides by 29, and I know that y is 9/29. Y is 9/29, and that is a 9. Sorry. Okay. Again, we're trying to find that point of intersection. So now that we know what y is, we can take this 9/29 and use either one of our equations to find out what x is. So I want to find x now. And I'm going to use my first original equation. And I'm going to plug 9/29 in the place of y. So now I have 6 times 9/29 equals 1. So that gives me 5x plus 54/29 equals 1. So I'm trying to isolate x, so I need to subtract 54/29. And we need to have a common denominator over there. So 1/1 and 54/29, the common denominator will be 29. So that 1 I can change into 29/29, and then I'm going to subtract the 54/29 over to the right-hand side. Now I have 5x equals 29 minus 54 gives me a negative 25/29. Okay, now I need to isolate the x, so I need to multiply by the reciprocal of 5, which is 1/5. That will allow that to cancel out with that one. And come over here and multiply by 1/5. So I have x equals, and as you can see, this 5 will go into 25 5 times. So x equals negative 5/29. So here's my x, here's my y. So my point of intersection is negative 5/29 and 9/29. Okay. Therefore, they intersect at one place, so I'll have one solution. That's how you would solve that using elimination. Okay, so again, the objective, get one of your variables to have the same number but opposite signs. Okay, let's look at a couple of